Hello everyone and welcome back. In this video we will create the shaders for our soccer ball, applying them to our model and set up our final render in Arnold. By the end we will have a clean, realistic final image ready to share. So let's jump right in. This is where we left off in the previous video. What I want to do now is to open up the Slate material editor, which is this one. And here will we add 3 physical materials. Next step will be renaming and assigning the physical materials. So this one will be SB black material. The next one will be SB white material. And the third one will be the background. Now, just for the purpose of being clean, we'll delete everything that we have put before, and we will apply each material to each object respectively. So first of all, let's go ahead and select SB black, click on this material and assign it, or we can just put right click and assign material to selection. Then we can go SB white, right click, assign material to selection, click on the background, right click on the material, assign material to selection. And just like that, we actually have the material set up as a basic setup. What I want to do next is work on the soccer ball shaders itself. So we're just going to pull it up something like this part of the software, and we're going to set the Slate material editor right here on the right side of our display. Let's dive in straight away. First of all, let's activate the active shade. So now we can see that we have the physical materials assigned. So first thing I want to do is add a curvature. In the search here, write curve, and we have the curvature. So we'll just put these 2 materials somewhere around here so we can work right here. So let's now connect the curvature to the base color map. So we see that it's black. Or we can also work on the white material simultaneously, so let's just connect it right there. And now we have the ball as a black shader. So we're going to change some parameters and then we are going to check what's happening. So we're just going to change the output to both, and we straight away have something green here that appears. Now we're going to set the samples to 6, the radius to 0.5 and the spread to 0.9. Something like this. And right away we have the curvature set. But what I want to do is add some noise to break up the curvature. So what we're going to do is search for a noise here and grab this OSL noise map, and we are just going to plug that in to the curvature's bias like this, and straight away you see it just breaks up, but because it's too big, it's going to break up in big parts. So let's set the scale to 1 and the gain to 1, and we'll leave everything else as default. So straight away we can see what's going on. Like the green parts is the curvature, and later we will add some dust. In order to view it better, we can grab and mix RGBA like this. We can set the first input. Let's go something like this: FF00D2. So we have this color in input 1, and in input 2 we'll set 009CFF, something like this bluish color. And in order to view it better, we're going to put the curvature into the mix here, and we're just going to plug that into the base color of both shaders like that. But to be honest, now actually we don't see it, right? And we barely see the curvature with these shaders, and this will be a problem with our shader later, because it will not show. So to fix that, we're going to add some sort of amplifier. So just search for lift, and we're going to add lift gamma gain, and we're going to plug that right here into the input and the output right there. So we have our node 3 something like this. We have noise, curvature, the OSL lift, and the mix RGBA. So now if we go into the lift node and set the gain to something about, let's say, 5, now we start to see it. So we're going to leave it like that for now. I think this is going to be okay. What I want to do now is switch the colors, right? But I'm not going to do in here. I'm going to add color. So go ahead and type in add and pull up this OSL add color. We're going to plug that in to the first input. And for A here, we're going to choose the color of 0B0B0B, which is black, but not sort of maximum value black. And we're going to click OK. Of course, because these two are mixed, we're getting some grayish color, but we're going to turn off the B scale right here on 0. And just like that, we have a black color, right? So for the next one, for input 2, for this input, we're going to just duplicate this map, set it right here, change the A scale to 0, the B scale to 1, and we get some grayish color right here, but I want to change that to, let's say, 898989, which will give us some deep gray color, something like this. Okay, and now we actually have set the curvature that we want to output in our shaders. Actually, we have finalized the shader, the base color for the black material, so we're just going to duplicate this, and we're going to put that into the white material base color like this. And we're going to change the color of the white material. So note that I will just move this down here so we know which is which. So this is the black and this is the white material. So let's go ahead and change the color right here to F7, 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 which is white, but not the ultimate white. So click OK. And then we're going to leave the second color as is, because we want the dust to be the same on the black and on the white parts. right? And so we actually have it right now. We've done both of the base color for white and for black material. Now next thing I want to do is add an ambient occlusion map. So we're just going to disable this both base colors and add an ambient occlusion node. We can add just one. So go ahead and plug that into the base weight map for both shaders. Base weight map, and you can see straight away that it drops some kind of shadows, but it's some kind of strange, so we have to mix something in the parameters to set it right. We're going to set the samples to 6. Next we're going to set the fall off to 0.2, right? And I think everything else we'll leave to default. So let's just try and disable that and go back. You see it drops some shadows on the parts. Like you can see shadows more clearly right here and in between the patches. Like this. Now we are going to replug the base color. So base color map. And this one also in base color map, and we have done the base color and the ambient occlusion for the soccer ball. As far as we go now, I would like to set up some roughness. So first, before we do anything, I'm going to tweak the physical materials right now. So into the basic parameters rollout, when we select the physical material, we'll find a section that's called reflection. So here we're going to set the roughness to 0.2 for the white material. Again, for the black material, when we select it, right here we have the roughness 0.2 again. So you can see that clearly in the render now. You can see like if it's 0, it's straight like a mirror reflection, and then 0.2 is somewhat of a blurry reflection, which we want for this material. And for the background material, we're going to set the roughness to 0.3. So that's it for now. Now let's do the actual roughness that we want to add to our material. So we're just going to, let's just add it like from here, because we'll get the default noise. And we will set the scale to 3, something like this. So we'll set the scale to 3. Yes, we will set the gain to 1. We'll set the low step to 0.3 and the height step to 0.8 as is. And next thing what we want to do is add a lift node, lift gamma gain node, and we will plug the noise that we have now into the input right here, and we'll set the gain to 0.3 just so we have a darker map like this, and we will plug this into the roughness map of both our shaders, so namely the SB black and SB white, just like that. And now we can see that we have some kind of fingerprints on our ball, something like that. So we're not going to go deeply into this issue, but the roughness will be looking something like the ball has been touched with hands. So that's my point. And for the next thing I want to do is move these both nodes somewhere here, right? And we are going to add a bump 2D from the Arnold map, this one. we're going to set this node into the bump map, move the bump somewhere here, just so we clearly can see an ambient occlusion right here. So next we're going to do is plug this into the bump map. So let's just drag out, leave it here, bump map. And now we have this dirty looking ball. And also we have these crevices on the edges, and that's because the bump map is too high. So what I'm going to do first is set the bump on the materials, so that just select SB white material and scroll down and set the bump map to 0.01. And also I'm going to do the same for the black material. Scroll down, find the bump map, 0.01, something like that. Then we're going to select our bump map, and in the parameters here we're going to set the bump height on 0.02, something like this. And just like that we've lost those artifacts that we got, but we kinda have the very subtle bump, which is maybe unnoticeable, but it's very, very subtle. So that's it for the materials now. I hope that you got it clear. If not, just rewatch the video, or even if you have any questions, feel free to ask me in the comments below. And I just want to clarify one thing before we go. And before we do anything, let's just set the background color. Let's just set it to some bluish color with a hex code of 5AAAE6. Something like this. And before we proceed, let me just clarify to you that we have actually three kind of materials here. So we have like 3ds Max material, like this noise, where it says maps general. That's usually a Max material, like this. Then we have an OSL material, which is universal for all softwares. And then we have a Arnold material, like standard surface, like this, and it's called materials Arnold. Another thing is that if we, this might be better, mix RGBA, yeah. So the thing is this, you can always go, like OSL map does not care if it goes before or after an Arnold map. But 3ds Max maps care about that, and if they go before Arnold map, that's okay. But if you put them after Arnold, then 3ds Max is like, what the hell? I don't know how to calculate this, and it mixes up some things and it just does not work. So keep that in mind, that if you ever add a 3ds Max material, add that material upstream, so it goes before you feed it to Arnold. If you want to do something, I haven't found a workaround, but I usually go first map 3ds Max and then just Arnold or OSL, and it's better if you leave out the 3ds Max maps. So that's just to keep in mind. Now I'm going to leave this like this, so you can clearly see the maps. And the next thing we will do is tweak out some render settings. So we can go ahead now and close the material editor, and we're going to restore max like this. We are going to grab SB black and SB white, both objects, and we're going to add an open subdiff modifier on it. So why I'm using open subdiff instead of turbo smooth is because turbo smooth just blindly smooths everything and forces to add extra support loops and sharp edges. Open subdiff on the other hand is smarter, and it lets you control the sharpness with grease weights, and it looks the same across different software, and it's more efficient on heavy meshes, so you actually get the same look without collapsing. So we're going to set the iterations to 2. We're going to set the UV boundary to smooth everywhere, and we're going to untick smooth triangles, and that's it, just on these 2 objects. After that I want to play around with the lights a bit. So let's just get the key light, change the color to something yellowish like 230, or just get this hex code, and we'll change the intensity to 3 and the exposure to 3. Then after that we're going to tweak the fill light. We're going to set some bluish color right here, so some 240 on the bluish color, or just this hex code. Just copy it, write this, and we'll set the intensity to 2.75 and the exposure to 2.75, and the rim light we will leave it as is because it has nice rim here. And the sky dome, finally we will set the sky dome intensity to 0.3, so we get pretty much lighter render. So we're just going to hack it like this, and let's just check the settings that we've set before. So these are the initial settings. We can cut off subsurface like this, and transmission also, I think. We can just do a final render and then tweak something else. So let's just render out, and I'll get back at you with this final test. So this is the final render that we've got. I mean, the final test render. This is not going to be the final render. After this, if you want, you can step up the camera AA samples to 6, just like that. Don't touch anything else. We can put volume indirect to 1, just for the laugh of it, and we can change the resolution to 2000. Just like that, and you are going to have a pretty much pro render at the end. So I will just render this out, and let's skip to the final render. And this is our final render that we have rendered out. It took me about 8 to 10 minutes to render out. So it's 2000 by 2000 resolution with the settings that I told you. And the most important thing is that we have a very clear image, that we don't have any noise or anything else. We can use this for whatever we like. And that's it, guys. Our soccer ball is fully shaped and rendered. I hope you enjoyed this little series. If you found it helpful, don't forget to subscribe and hit the like button. It really helps the channel grow. Also, let me know in the comments what you'd like me to model next, or if you have any requests for future tutorials. Thanks for watching, and I'll see you in the next one.